Hello everyone and welcome to this video on ratio and proportion. In this video we'll discuss some basic concepts of ratio, then we will see how to compare two ratios, then we'll discuss some concepts of proportion and variation, and finally we'll solve some problems based on these concepts. So let us begin. Any number which can be expressed in the form of a by b is called as ratio. For example, 1 by 2 is a ratio, 3 by 4 is a ratio, 6 by 5 is also a ratio. The part in the numerator 1, 3, 6, these are called antecedents. And the part in the denominator 2, 4, 5, they are called consequents. As I have discussed in my video on percentages, ratio and percentages are interchangeable. So to convert a ratio or a fraction into a percentage, all you have to do is multiply the value by 100. So if you multiply 1 by 2 by 100, you will get 50%. Similarly, if you multiply 3 by 4 by 100, you will get 0.75 into 100, that will be 75%. Likewise, 6 by 5 into 100 will give you 120%. So in this way, you can convert a ratio into a percentage, and to convert percentage into a ratio, all you will have to do is divide this percentage by 100. You will get back to the ratio. So this will be 1, this will be 2. So your ratio will become 1 by 2. Now if you take any ratio, let's say a by b, and if I square it, so this will become a square by b square. Then this ratio is called as duplicate ratio. And if I take the square root of these values, so it will be square root a upon square root b. This is called the subduplicate ratio. If I cube this value, we'll get a cube by b cube. This is called the triplicate ratio. And if I take the cube root of these values, a by b, we'll get cube root of a upon cube root of b. This will be called as subtriplicate ratio. So this is the basic definition of ratios. Let us now understand what is proper fraction and what is improper fraction. So if the value of this ratio a by b, if this value is less than 1, or in other words, if a is less than b, if a is less than b, then the value of a by b will be less than 1. Then such a ratio or a fraction is called as proper fraction. And if this value of a by b is greater than 1, or in other words, if a is greater than b, then this value will be greater than 1. Then such a ratio or such a fraction is called improper fraction. Now in case of proper fraction, where a by b is less than 1, if I add some quantities, let's say c, to both the numerator and denominator, then the value of the ratio will increase. That means a plus c upon b plus c, where c is a constant, will be greater than a by b. So to the original ratio a by b, I have added c to the numerator and c to the denominator. Then this value will become greater than the previous value. On the similar lines, if I subtract c from the numerator and denominator both, I'll get a minus c upon b minus c, and this value will be less than the original ratio, which is a by b. Whereas in case of improper fraction, the reverse will occur. So in case of improper fraction, a by b is greater than 1. So if I add c to both the numerator and denominator, so I'll get a plus c upon b plus c, and this value will be less than a by b. It is just the opposite of the proper fraction. And if I subtract c from both the numerator and denominator, then this value will become greater than a by b. Let us take a few examples and understand. So in case of a proper fraction, if we take this value 1 by 2, 1 by 2 is a proper fraction. If I add 2 to the numerator and 2 to the denominator, what I'll get? I'll get 3 by 4. Now 1 by 2 is nothing but 0.5. What is 3 by 4? It is 0.75. So as we can see, this new value after adding 2 to the numerator and 2 to the denominator is more than the original value, which is 1 by 2. So this was our first condition. Now if I take for the second case, let's take this example 5 by 6. A is less than B. So if we subtract 2 from the numerator and 2 from the denominator as well, we'll get the value as 3 by 4. Now 5 by 6 was our original ratio. Its value is 1.2. 3 by 4 is a new ratio. After subtraction, its value is 0.75. So this new value has become less than the original value. So if you subtract same quantity from the numerator and denominator of a proper fraction, the value of the ratio will decrease. So this new ratio will become less than the original ratio. Let's take few examples for improper fraction and also understand this concept. If I take this example, let's say 3 by 2. Since A is greater than B, this is an improper fraction. So the value of this improper fraction is 1.5. If I add, let's say 3 to the numerator and 3 to the denominator as well, I'll get the value as 6 by 5. Now 6 by 5 is equal to 1.2. Now clearly 1.2 is less than 1.5. So in case of improper fraction, if we add some constant term in the numerator as well as the denominator, the new ratio will become less than the original ratio. As you can see, 1.2 is less than 1.5. Similarly, from this ratio 3 by 2, which is an improper fraction, if I subtract, let's say 1 from the numerator and 1 from the denominator as well, I'll get the ratio as 2 by 1. Its value becomes equal to 2. 3 by 2 was equal to 1.5. Now 2 is clearly greater than 1.5. So if we subtract the same quantity from the numerator and denominator of an improper fraction, the new ratio will be greater than the original ratio. So here in this case 2 is clearly greater than 1.5. This is a basic fundamental rule related to proper and improper fraction which will help you in problem solving. Let us take proper fraction and explore further. So in case of proper fraction, as I have discussed earlier, A by B is less than 1. Now to this proper fraction, if I add C to the numerator and D to the denominator, so what we are getting? A plus C and B plus D. So if this ratio C by D, the new terms that we have added in the numerator and denominator, if it is greater than the original ratio A by B, if this is the case, then A plus C upon B plus D, that is the new ratio, will also be greater than the original ratio A by B. This is only applicable in case of proper fraction. Likewise, if C by D is less than A by B, then this new ratio A plus C upon B plus D will also be less than A by B. If C by D is equal to A by B, then this ratio A plus C upon B plus D will also be equal to A by B. Please remember these rules. These are very basic and simple rules. It will help you in solving problems. Let us now see how to compare two ratios. Suppose you have been given two ratios, let's say R1, which is equal to N1 upon D1, where N1 is the numerator part and D1 is the denominator part. And there is another ratio R2, which is equal to N2 upon D2. Now if you want to identify which ratio among R1 and R2 is bigger, so the obvious way to do is divide the numerator by the denominator and get the decimal value of this A point B or something. Similarly, in this case also you will divide the numerator by the denominator and get the decimal value and then compare it. So in this case calculation is involved. But in exam you do not have to calculate every time. Based on the numbers which are given in the ratio of the numerator and denominator, you can use certain tricks to identify which of the ratio is bigger. So let us explore one by one. We'll consider four different cases. In the first case, we'll keep the denominator constant, and in the second case, we'll keep the numerator constant and see how to identify which of the ratio is bigger. And in addition to that, with respect to the first ratio, we'll change the numerator and denominator in the opposite direction. So if the numerator is increasing, we'll decrease the denominator, and if the numerator is decreasing, we'll increase the denominator. And in the third and the fourth cases, we'll change the numerator and denominator in the same sense. We will increase both the numerator and denominator and compare which one of the ratio R1 and R2 is bigger, and we will decrease both the numerator and denominator and see which of the ratio is bigger. So let us consider one by one. In the first case, we'll keep the denominator constant. So D2 is same as D1. So in this case, if your N2 is greater than N1, then your second ratio will be greater than your first ratio. And if your N2 is less than N1, then your second ratio will be less than your first ratio. This is very simple. I hope you will be able to understand this. 3 by 4 will be less than 5 by 4 and 3 by 4 will be greater than 2 by 4. So the denominator is constant, numerator is increasing. So the ratio is increasing. 5 by 4 is greater than 3 by 4. Again, the denominator is constant, but the numerator is decreasing. So your first ratio is bigger than your second ratio. Then we'll consider the second case in which we are going to keep the numerator constant. So n1 will be equal to n2. So in this case, if your denominator is increasing, that is d2 is greater than d1, then your second ratio will be less than your first ratio. That is r2 will be less than r1. And if your denominator is decreasing, that is d2 is less than d1, then your second ratio will be greater than your first ratio. If we take the example, let's say 5 by 3 and 5 by 4. So clearly your denominator has increased. So d2 is greater than d1. Hence your second ratio, that is 5 by 4, will be less than your first ratio. Similarly, if we consider this ratio 5 by 3 and 5 by 2. So your denominator has decreased. So your second ratio will be greater than your first ratio. You can divide the numerator by denominator, find out its decimal value and compare the result. Now let us consider what will happen when both the numerator and denominator are changing in opposite direction. So let us consider that your denominator is decreasing and your numerator is increasing. So in this case, the numerator is increasing, n2 is more than n1, and your denominator is decreasing. So d2 is less than d1. So in such a case, the same concept will apply. That is, your second ratio will be more than your first ratio. We'll see what will happen when your denominator is also decreasing and numerator is also decreasing in your third case. Similarly, in the second case, when your numerator is increasing, that is n2 is greater than n1, and your denominator is decreasing, that is d2 is less than d1. So in this case also, the same rule will apply. That is, your second ratio will be more than your first ratio because your numerator is increasing and your denominator is further decreasing. So your second ratio will become more than your first ratio. Let us now consider the third case in which both the numerator and denominator are increasing. This is an interesting case. So your numerator is increasing, n2 is more than your n1, and your denominator is also increasing. So d2 is also more than d1. So in this case, we cannot directly conclude. In case 1 and case 2, and even in the cases where your numerator and denominator are increasing or decreasing in the opposite direction, we could directly say that which ratio is bigger and which ratio is lesser. But in cases where the numerator and denominator are increasing or decreasing in the same direction, we'll have to make some calculation. Let us consider this example. Let's say if the first ratio is R1 125 upon 90 and your second ratio is 150 upon 110. So in this case, your numerator is also increasing and your denominator is also increasing. So we cannot conclude directly which of these ratio R2 is bigger than R1 or R1 is bigger than R2. So in this case, we'll have to make some calculations. We'll find the percentage increase in the numerator and the percentage increase in the denominator. If the percentage increase in numerator is more than the percentage increase in the denominator, then R2 will be greater than R1. And if your percentage increase in the numerator is less than the percentage increase in the denominator, then R1 will be more than R2. So for this example, if we consider your numerator is increasing by 25 over 125, so the percentage will be 1 by 5, which is 20%. So your numerator is increasing by 20%. And in case of the denominator, it has increased by 20 over 90. So 20 by 90, the percentage value will be 2 by 9, which will be 22.22%. So in this case, the percentage increase in the denominator is more than the percentage increase in the numerator, which is the second case. Hence, your first ratio will be more than your second ratio. Let us consider the fourth case where both the numerator and denominator are decreasing. So if your numerator is decreasing, that means your second numerator is less than your first numerator and your second denominator is also less than your first denominator. So in this case also, we cannot directly conclude which of the ratio is bigger. We'll have to make some calculation. Let us consider these two ratios, R1 equal to 270 upon 175 and R2 equal to 240 upon 150. So in this case, as you can see, your numerator is decreasing and even your denominator is decreasing. In this case, exactly the reverse of the third case will occur. So if your percentage decrease in the numerator is more than the percentage decrease in the denominator, then R1 will be bigger than R2. In this case, R2 was bigger than R1. And in case your percentage decrease in the numerator is less than the percentage decrease in the denominator, your R2 will be bigger than R1. In this case, when the percentage increase in the numerator was less than the percentage increase in the denominator, R1 was bigger than R2. Whereas in this case, when the percentage decrease in the numerator is less than the percentage decrease in the denominator, your R2 is greater than R1. So if we take this example, if you find the percentage decrease in the numerator, so numerator is decreasing by 30 over 270, so the percentage value will be 1s are 9s are, it will come out to be 1 by 9 into 100, that will be 11.11%. Whereas the percentage decrease in the denominator, your denominator is decreasing by 25 over 175, so this will be 25 over 175 into 100, this will be 1s are 7s are, so 1 by 7 it will come out to be 14.28%. So as you can see, your percentage decrease in the denominator is more than the percentage decrease in the numerator. So this is based on the second case. Hence we can say that your second ratio R2 will be greater than R1. You can check using the calculator. If you calculate this ratio 270 upon 175, it will come out to be 1.54. And if you calculate this ratio 240 upon 150, it will come out to be 1.6. So R2 is clearly greater than R1. So in this way you can compare two ratios. Let us now understand the concept of proportion and variation. It is just the continuation of ratios. So if we have two ratios, R1 equal to A by B and another ratio R2 which is equal to C by D. So if these two ratios are equal, R1 is equal to R2, then the quantities forming the ratio, that is A, B, C and D, they are said to be proportional. Since these two ratios are equal, we can say that A by B is equal to C by D, or in other words we can say that A is to B will be equal to C is to D. That means A, B, C and D are proportional to each other, where A and D are called extremes and B and C are called means. So when four quantities are proportional, A by B is equal to C by D, you can use the following rules. Number one is the invertendo. If A by B is equal to C by D, then B by A will also be equal to D by C. The second rule is the alternando. So if A by B is equal to C by D, then A by C will also be equal to B by D. The third rule is the componendo. It is nothing but adding 1 to both the sides. So we'll have A by B plus 1 will be equal to C by D plus 1. So we will get A plus B upon B will be equal to C plus D upon D. The fourth rule is the dividendo. In place of addition, we'll subtract 1 from both the sides. So we'll have A by B minus 1, it will be equal to C by D minus 1. So we'll have A minus B upon B will be equal to C minus D upon D. And the fifth rule is the combination of componendo and dividendo. All you'll have to do is divide this equation by this equation. So we'll have A plus B upon A minus B, which will be equal to C plus D upon C minus D. So in case when two ratios are equal, then the quantities forming the ratios will be proportional. And when four quantities are proportional, that is A by B is equal to C by D, you can make use of these 5 rules to simplify your calculations. Let us now understand the concept of variation. There are two types of variations basically. Number one is the direct variation, and the second one is the indirect or inverse variation. So in direct variation, what happens? Let's say there are two quantities where A is directly proportional to B. So A is varying directly with respect to B. That means A by B is a constant. So if we plot the graph of A and B, if we take A on the y-axis and B on the x-axis, so if A is increasing, then B will also increase. If A is decreasing, then B will also decrease. So if A is increasing by 10%, B will also increase by 10%. If A is decreasing by 10%, then B will also decrease by 10%. Whereas in case of inverse variation, A is inversely proportional to B. So A into B, the product will be a constant. In case of direct variation, the ratio of A by B will be a constant, whereas in case of inverse proportion, the product of A and B will be a constant. So if we plot the graph of A and B, so if B is increasing, then A will decrease. So with increasing B, the value of A is decreasing. So if A increases by 10%, then B will decrease by 9.09%. From where this value of 9.09 is coming, I have explained this concept in a video on percentages. You can watch that. So this is about direct variation and inverse variation. Now we will solve some problems based on these concepts. Let us take this example. The ratio of milk and water in a 70 liter of mixture is 3:4. Find out how much quantity of water should be added so that the ratio of milk and water becomes 1:2. So the current ratio of milk and water in this 70 liter is 3:4. So how to find what is the quantity of milk and what is the quantity of water in this 70 liter? So for that we'll assume that the quantity of milk is 3x and the quantity of water is 4x. So the total quantity will become 3x plus 4x, which will be 7x. And this total quantity is given to us as 70 liters. So this will be equal to 70. From here we will get x as equal to 10. So if we substitute the value of x over here, we'll get the quantity of milk in this mixture. And if we substitute it here, we'll get the quantity of water in this mixture. So milk will become 30 liters and water will become 40 liters. So this is the basic principle by which you can find the quantities in a given ratio. But you don't have to do all these calculations. You can easily find out what will be the quantity of milk and water without doing all this calculation. So if you want to find out what will be the quantity of milk, we'll take the ratio of milk, which is 3, and divide it by the sum of the ratios. This will be 3 plus 4, which is 7, and multiply it with the total quantity, which is 70. So you will directly get the quantity of milk, which will be 7 into 10 will be 70. This will give us 30 liters. Similarly, if you want to find out what will be the quantity of water, you take the ratio of water, which is 4, divided by the sum of the ratio, which is 3 plus 4, 7, and multiply it with the total quantity, which will be 70. So the quantity of water will come out to be equal to 40. So now initially the quantity of milk, let's say M1, is 30 liters and quantity of water is 40 liters. Now by adding some quantity of water, we have to make this ratio of milk and water as 1:2. So now after adding additional quantity of water, let's say the ratio will become M2 upon W2. The quantity of milk will remain the same, which is 30, but the quantity of water has been increased. Let's say it has been increased by X amount. And this ratio is now becoming equal to 1:2, which is 1/2. So all we have to do is solve for X, and this will give us the value of the quantity of water that should be added to this mixture to make the ratio as 1:2. So we'll cross multiply and solve this. This will become 60 equal to 40 plus X. So from here we'll get X equal to 20 liters. So we'll have to add 20 liters to this mixture. Then the ratio of milk and water will become 1:2. Let us take the next example. The ratio of present ages of two persons A and B is 5:3. 10 years from now, the ratio of their new ages will be 7:5. Find their present ages. So the ratio of present ages of A and B is given. So A is to B is given to be as 5:3. So we'll assume the present ages as 5x and 3x. This is the present age of A and this is the present age of B. So 10 years from now, since their present age is 5x, 10 years from now their ages will be 5x plus 10 and 3x plus 10. 10 years from now, the ratio of their ages will be 7:5. So if we take this ratio, 5x plus 10 upon 3x plus 10, this ratio will become equal to 7 upon 5. And we have to find what will be the present ages. So if we are able to find what is the value of x, we can substitute over here and get what will be the present ages. So for that, we'll cross multiply this and solve. We'll get 25x plus 50 will be equal to 21x plus 70. So 25x minus 21x will give us 4x, and this will be equal to 70 minus 50, which will be 20. So the value of x will come out to be 5. So their present ages will be 5x, which will be 5 into 5, 25, and the present age of b will be 3 into 5, which will be 15. So this is how you can solve this problem. Let us take the next example. Income of two persons A and B are in the ratio 3:4, and their expenditures are in the ratio 1:2. If each of them save 1000 rupees, find A's income. So there are two persons A and B. Their income, which is in the ratio 3:4. So we'll assume their income to be 3x and 4x. And their expenditures are in the ratio 1:2. So we'll assume their expenditures to be equal to y and 2y. Now each of them is saving 1000 rupees. So what will be the saving? Saving is nothing but income minus your expenditure. So this will be your saving. So A's saving will be 3x minus y, and this is equal to 1000 rupees, since each of them is saving 1000 rupees, and B's saving will be 4x minus 2y, and this will also be equal to 1000 rupees. So we have two equations, two unknowns. We can solve them. Once we obtain the value of x and y, we'll substitute the value of x in this equation, 3x and 4x, we'll get the income of A and B. So for solving this equation simultaneously, what we'll do is we'll multiply this equation by 2. We'll have 6x minus 2y will be equal to 2000. So now from this equation, we'll subtract this equation. So this will be minus plus minus. So we'll have 6x minus 4x will be 2x, minus 2y plus 2y will cancel out, will be 0. 2000 minus 1000 will be 1000. So we will get the value of x as 500. Once we have the value of x, we can even find the value of y, but we don't need to find the value of y for this question. By using the value of y, we can find what will be the expenditure. But in this case, we just have to find what is A's income. So A's income is 3 times x. So it will be 3 into 500, which will be 1500. So this is how you can solve this problem. Let us take the next example. In this example, there are two types of alloys of tin and copper. So alloy is basically a mixture of two or more material. So in this case, the two materials are tin and copper. The first type consists of tin and copper in the ratio 3:7, and the second alloy consists of tin and copper in the ratio 5:9. If the two alloys are mixed together in the ratio 1:2, then find the ratio of tin and copper in the final mixture. So there are two types of alloys of tin and copper. We are mixing them in the ratio 1:2, and we have been asked to find the final ratio of tin and copper in the mixture. So let's say we have the alloy 1. It consists of tin and copper. It is in the ratio of 3:7. We'll assume the quantity of tin as 3x and the quantity of copper as 7x. And in the second alloy, the ratio of tin and copper is 5:9. So we'll assume tin as 5y and copper as 9y. So the total quantity of first alloy is 3x plus 7x, which is 10x. And the total quantity of the second alloy is 5y plus 9y, which will be 14y. And these two alloys are now mixed in the ratio 1:2. So if we take the total quantity of first alloy and the total quantity of second alloy, and if we divide them, this ratio will come out to be equal to 1/2. So 10x upon 14y is equal to 1/2. So if we solve this, we'll get the value of x by y, which will be equal to 2 1s are 2 7s are as 7/10. So we have the value of x by y as 7 upon 10. Now what we have been asked to find is the final ratio of tin and copper in the mixture. So in the final mixture, the total quantity of tin will be 3x plus 5y. From the first alloy we are getting 3x tin. From the second alloy we are getting 5y tin. And the final quantity of copper will be 7x plus 9y. And if we take the ratio of tin and copper, which will be 3x plus 5y upon 7x plus 9y, this is the ratio that we need to find out. We have the value of x and y. We can use this value and find it out. So what we will do is we'll take y common from the numerator and y common from the denominator. This will be equal to, if I take y common, I'll have 3 into x by y, since y I have taken common, plus 5. And in the denominator also we'll take y common, we'll have 7 times by y plus 9. So this y and this y will cancel out. We have the value of x by y, we'll substitute it here, so we'll get 3 into 7 by 10 plus 5 divided by 7 into 7 by 10 plus 9. So the numerator will become equal to 3 into 7, 21. We'll multiply this 10 by 5. So we'll get 50, and this will be divided by 10. And in the denominator we'll get 7 into 7, which will be 9. And this 10 will multiply with this 9. We'll get 90 over here. And this thing will be divided by 10. 10 and 10 will cancel out. We'll get 71 in the numerator. And in the denominator we'll get 90 plus 49. That will be 139. So the ratio of tin and copper in the final mixture will be 71 upon 139. So in this way you can solve these problems. So this is all about this video. In the next video we'll solve some more problems based on the concepts of ratio and proportion. Thank you.